Hello everybody, welcome back to From Rhythm to Algorithm, part 77, I believe. This one is called Connecting the Dots. So in this series, as well as with my other scientific lectures, we've established and discussed a ton of different history, fundamental science, proof, mathematics, and linguistics, and a bunch of other things. But what we're going to do in this episode today is kind of review our logic pyramid, extend that logic into a different model. I've hand-drawn some graphs and some visuals. I'll put them up here on the screen here in a second. But just give you something to visualize. But again, it's not the visuals, the geometries, the shapes is not that super specific. It's just listen to the merits of what's coming out of my mouth. But we've identified very simple physical principles, rhythm and vibration. We have showed and demonstrated that there is a huge gap, fundamental physics evolving over the years to have this discrepancy between general relativity and quantum mechanics, or really particle physics, the standard model of particle physics, the different discrepancies. General relativity can account for things that are really small. We've discussed discreteness and what quanta are extensively in the previous episodes. And then the standard model of particle physics can't quantize gravity. So we've discussed that ad nauseum to the point where it's very clear that vibration and rhythm are fundamental physical phenomenon. Right, good vibes only. Turn on any sports thing, watching people do active motion, and everyone's trying to pick up a rhythm. They're in a rhythm. They're in a groove. So it's overwhelmingly apparent that vibration and rhythm are fundamental physical principles. And now I'm trying to show how that ontology, building up the logic, or I guess in the last, in the logic pyramid, we use it as building down. You get a point, you get a point, you get a point, and once you get an entire level like Tetris, it wipes out, but as opposed to Tetris, you build. So you're building down, again, down, up, left, right, forward, backward, doesn't really matter, it's just a visual, it's just something to think about. But we're trying to take, again, we've made a clear differentiation that there's censorship, me making a choice, censorship with an S, making a choice to not to filter something, and then censorship meaning a physical censor, like a mechanical thing. I put a quarter in an old school pinball machine, or a quarter machine, or whatever, and the physical weight and size of the coin gets filtered out mechanically. Right? So, what was I saying? I forget. But we're going to try to find, again, show that the difference between censorship spelled with a C and with an S, and intuitively, instinctually, everyone knows what censorship is. And so I'm literally just nitty-gritty getting down to the logical details as why you spell one with a C and one with an S. We're going to take that very general word, that general set of concepts, and we're going to derive it into a specific result. And that specific result, I don't know what it is yet, or so I would directly tell you right now. But really what it's going to be is the minimum amount of words that are required to articulate a fundamental physical principle, which will become an axiom by demonstrating, by taking a known unknown and making it a known known. So we're going to again review our logic structure that we're working with, and then we're going to get into, again, just talk about different physical principles. Last episode we did a lot of connecting logic, just literally out loud in real time, trying to pin down more poignant and insightful results. So right now I'm going to pause and I'm going to bring up the diagrams. So first, again, I'll put it up here in my actual editing, but I just have this. I'll be looking at this in this little section. And so if you've not seen the logic pyramid, I think it was part 74 or 75, but it's called the logic pyramid. It's in this series. Go watch that because we're just quick review. In that episode, we just discussed how a simple fact transmits in the known area. Just one fact, reason two, reason one. If they're at disagreement, you, as they would say in fundamental physics today, you renormalize. You use an empirical measurement to say why one's true or one's the other. Again, the empirical world always validates a fact, not any one individual or one bit of reason. And so, again, the merits of logic speak for themselves. And so we just have that, but that was just on an individual basis. And we'll actually revisit this next episode with some more insight and more development. But again, we covered all of that. If you want to, but that is just one one fact being deduced into two different conclusions from two different people. And so now I wanted to generalize that even more with a visual. Again, this is when I would use just elements of graphics for editing, but don't have an editor, and I'm not a super developed editor, so I don't really care. I mean, just if you're listening to these videos, you're going to actually want to pay attention and listen, so the visuals aren't that important. But again, this one's up here on here, or the logic pyramid extended. Again, if you view the top of one as the, kind of like the surface of the sand and this pyramid building down, you connect each vertex, and then like Tetris, once you get them all across, that level becomes you unlock a new level, unlock a new level, unlock a new level. In this one, as you can see, again, the pyramids are pointing up, or it's indiscriminate. Doesn't really matter, but it's just a visual to give you some sort of thing to have in your mind. And so, you see, so this square represents all of reality. Again, the boundary is unbounded between one and just like the sides, like the outsides of the square, not even bordering the triangle. You can't make any statement on that. Then you have the triangle labeled 2, and so everything contained within the purple region is well-defined conjectures, which are our known unknowns. We have this thing there, we have this thing that's true, we have this thing that's true. Can we take that logic a step further? Can we derive another fact true based off all of these other things and say why it's true with empirical evidence? And so again, that's our sensorality, differentiating between C and S, right? If I say I have senses, everybody would say that's senses with an S. If you say censorship, everybody right now on their TV, Bill Maher or Piers Morgan, uncensored with a C. And so people use those haphazardly in a sloppy, logical way. And so I'm trying to get to that linguistic, the representation by words that show you this fact that is undeniable. And so when you go from that boundary from 1 to 2, we'll get to that. But so the region of 2 is your known unknowns. You know enough things to make conjecture something else that you think this is true. Those are all the things you think. I think this is true because of this. I think that is true because of that. And that's the set in the space of well-defined conjectures. And then the red section, the number 3, and that's really what we got to with the original logic pyramid video. But that's the set of all known facts, right? I might not know something, Johnny over there knows something, that something is part of the set of known facts, the known knowns, it's just not known by me personally, my reference frame. And so that's the set of all knowns is the red triangle, and the blue triangles, the space 4, is the knowns by a single individual. And so that's just personal knowledge. And so when you go from, consider that, you're a person, you're in number 4, you know something, and you go to school, and you learn another fact. You learn, I don't know, that the capital of South Dakota is Pierre. It's a fact. It was known by the rest of the species, or not by the rest of the species, but it was known, and now you know it. So you know something that was already known, a known. So you learned something. That's the set of all things learned. And then you can go from where mathematics really gets to, and again, every human being that's ever existed, every organism that's ever existed has gone from 4 to 3, has brought knowledge from a piece of a fact, one of those vertices in the 3 region, and brought it to the 4 to their own personal knowledge bank. It's literally learning. And then the boundary from 2, well-defined conjectures, to the set of all known facts, right? The boundary between 2 and 3 in our triangles. The entirety, right? Nobody knows how. Is there a smooth and continuous solution to the Navier-Stokes equation? Is there a pool table sitting right next to me? Is there a pen in my hand? Some of those are known, some of those are unknown. Some of those are unknown by the entire species, by the entire ontology. So a conjecture, especially in fundamental ontology, as specific and general, again, the proofing structure comes between going from specific, that is the unknown, the known unknown of sensorality with an S. That is the word. I'm trying to find you the other logical connection between the words, and I would just tell it to you if I knew it, like literally right now today as recording. But as I've already done with speciality, I've already done this entire process. And so what I'm doing, where you get the concept of proof, is when you go from, you build enough, and really these should be circles, but we're using discrete objects because we're using, again, from our last video, a measurement limit. So everything that is limited will appear discrete at a different scale, but the fundamental scale is all fractal, so it's all the same. It's just literally how big you are in relation to something else, and that gives you measurement limits. And so that's why we're using discrete objects instead of circular, but it'll be a lot kind of easier to visualize. You get a circle, concentric circle getting bigger and bigger and bigger as your knowledge grows, or as the knowledge of the species grows. But then again, remember, you can't square the circle, or you can't square the circle, because literally, given a unit length of 1, a square has more area than a circle with a radius of 1, and that area between the square and the circle, that's infinitesimality, which is really the logical foundation for an infinitesimal, right? From rhythm to algorithm, we have to integrate all knowledge, and that's my other lecture series, but it's pulling all of this logic together. And so, like we also discussed last video, or in the Chris Langdon one, you have to pull all of this logic together to demonstrate and prove the bare minimum. Establishing speciality as an axiom allows other people to derive true facts based off speciality, not just me. And so you see the enormity of information you really have to process and personally understand to go from that 4 region all the way up to that 2 region, to bring a vertex from 2, to bring a piece of information from 2, a known unknown, and that becomes into the 3 region, which is just the known knowns. I think the Riemann hypothesis is true. I think the Riemann hypothesis is true. Here's why it's true. We took a known unknown and we provided a new fact or a new bit of reasoning to unlock a new vertex point in our logic pyramid, and now that is established. And bam, it is known throughout the species, and it gets transmitted like we have demonstrated with our logic pyramid on the person-to-person basis. And so again, 3 to 1, and when you do that, when you take a fact from the well-defined conjectures and you take a bit of information from reality, again, just right here we have reality, and you take that and then you establish it, and now it becomes a known known, you expand the boundaries of all the triangles. Your personal knowledge is increased, that's why you have the intuition to articulate a new fact. The known knowns of the entire species or of any given group has increased, and because you've established that new fact by bringing a piece of information from just from a raw empirical fact to a known known, that boundary between the well-defined conjectures can expand farther as well. So that is really how logic expands and contracts, and contracting, the contraction part, bringing that information back, is what really establishes proof. You take a bit of knowledge from region 1, you are a person 4, it sits in region 2 for a while, even if it's only on a personal level. I mean, you can have personal conjectures, meaning you're aware of something that is a true fact or a true logical derivation from region 3, the known knowns, and nobody else knows you know that, right? And so you can go from region 4 to region 1 in one go, but you have to bring back a bit of information, a fact from region 1, establish it, show how it relates or pairs to some open conjecture in region 2, and then once you prove that, you show and in my case, a complete linguistical proof shows the consistency of the letters that represent the logic that you're describing. And so there's a ton more, and this is when we get into geometric linguistics, when I talk about the shapes and consistencies of letters. There's a bunch of axioms, or not axioms, but relationships that I've proven true extensively years ago that all still apply, even though that nobody else knows them. And so I'm holding my proofing standard to my own intuitive standard of showing the consistency of letters. But again, clearly I've shown enough logical intuition of vibration and rhythm, as well as sensorality, differentiation, and I've already done this entire process. To the people just watching this, again, if it ever gets known before people actually understand how involved my proofing is, I have been doing this derivation continuously for 25 years with a math subject sitting on people's desks for over 8.5, going on 9 now, going on a decade. So that's fun stuff, but that is, I don't know what I'll call it or what I'll title that. I might just make this 2 parts, but now what we're going to do, regardless, I'll just decide if this is going to be 2 parts in the editing. But we're going to take this, I just wanted to have you have this in your mind. We're going to get back to it next episode, either after this one or if I make this one too. The next episode will be showing this kind of geometric or just graph representation of the Dunning-Kruger effect in different examples pulled from the real world. My experience is me observing two other people that don't know me and I don't know them, just observing language in the wild more so, but really picking out examples where it shows the Dunning-Kruger effect in real time on Reddit, in the news, whatever, just for some examples, as well as I'll draw up some more diagrams. And now let's get back to the actual, just the fundamental physics.